I've been getting some questions on these three lessons that I had you guys do for the time that we were supposed to miss, 7.1, point 2, and point 3. And I figured I would just do a quick walkthrough of the three lessons, kind of like we're in class, so that if you guys are still working on those assignments or if you want to go back and take a look at them, you can see what we need to be doing here. So let's get started. On 7.1, we were learning about multiplying monomials. So first of all, we need to know what a monomial is. A monomial is a number, a variable, or a product of a number and one or more variables. It can include exponents. What they cannot include are division, subtraction, or addition of any variables. So the only mathematical operation that a monomial can include is multiplication. No division, subtraction, or addition. So what we're going to do here is we're going to take a look at some examples and determine whether or not they are monomials. So this first one, negative x plus 5. If we were to take a look at that one, we would say that no, this one is not a monomial because we know that it cannot include addition. And in this case, negative x plus 5, it does include addition, so that one could not work. Here, 23abcd squared. So here, what we're really saying is 23 times a times b times c times d squared. So in this case, we've got numbers, we've got variables, we've got an exponent all multiplied together. So yes, that would be a monomial. Now in this one, this is where it gets a little bit tricky. If we have x times y times z cubed over 2, in this case, we were told that we can't have a monomial if it includes division. But really what that means is if we are dividing by a variable. In this case, we're dividing by a number, which means this could be rewritten as 1/2 times xy z cubed. Now if we look at it this way, that would technically be all multiplication. So we would say yes, that is a monomial. And then this is that other case. If we have a times b over c, in this case we're dividing by a variable. So we would say no, because it divides by a variable. So that's how we can tell whether or not something is a monomial. Now, if we take a look at product of powers, so in this case, we're working on multiplying monomials. When multiplying two or more powers, which again are the numbers or variables with an exponent, we add the exponents. So in this case, 2 cubed, 2 to the 3rd power times 2 to the 5th power, would end up giving us a solution of 2 to the 8th power. Now the reasoning for that is because if we write out 2 cubed, it becomes 2 times 2 times 2, times 2 to the 5th would be 2 multiplied by itself 5 times. If we add all of those up, there's 3 2's there, we're multiplying it 3 times. We're multiplying it 5 times there. 3 plus 5 is equal to 8. So if we take a look here, simplifying the expression. Now, what we want to do when we're multiplying monomials. First, you want to look at the numbers. You are the coefficient, the number in front. And you want to multiply those coefficients. So here we've got 5 times x to the 7th times x to the 6th, which in this case, if there's no coefficient there, then it becomes a 1. So 5x to the 7th times x to the 6th, 5 times 1 is 5. Then we've got x, since we're multiplying x to the 7th times x to the 6th, we would add our powers, and that becomes x to the 13th power. This one, negative 4 times negative 6 gives us a positive 24. R times r to the 5th, if there's no exponent, you can put in a 1 as a placeholder. So 1 plus 5 would give us r to the 6th. s to the 2 plus 2 is the 4th power, and then t cubed times t cubed would give us t to the 6th power. Then moving on to powers of monomials. So here, when raising a monomial to a power, you multiply the exponents. So on the last slide, we talked about multiplying powers. So x squared times x cubed, we would add them. It would become x to the 2 plus 3 equals x to the 5th. Here, we're talking about raising a monomial to a power. So in this case, if we had x squared and we raised it to the 3rd power, instead of adding our exponents, we would multiply them. So it would become x to the 2 times 3, which would be x to the 6th. So in this case, what we're going to do is we have 3 squared to the 3rd power, and then we're squaring that. So what we're going to do is inside our brackets here, 3 squared to the 3rd power, just like we just did over there, would become 3 to the 6th power. Then if we squared that, 3 to the 6th squared, what we would need to do here is multiply 6 times 2, and it would give us 3 to the 12th power. And then same thing here. 2 squared squared would give us 2 to the 4th power. 2 times 2 is 4. Then we're raising that to the 4th power. 4 times 4 is 16. So this would give us 2 to the 16th power. So here, express the area of the square as a monomial. Since this is a square, we know all of the sides are congruent, so we can write in that this side would be represented by 4AB. So here we would go to find the area of the square, length times width. So 4AB times 4AB, which can also be written as 4AB squared. Now, what we need to do here, we can look at it in 2 different ways. This first one, going back a couple slides, we multiply our coefficients first. Becomes 16. A times A gives us A squared. B times B gives us B squared. Or if we look at it this way, when you've got something in parentheses and you're raising it to a power, you have to distribute that power. You have to raise everything to that power. So 4 squared would give us 16. Then A squared, B squared. So 2 different ways, same solution. This one here, area of the rectangle. So again, length times width. We would have 2xy squared times 6x cubed y to the 4th. So we're going to multiply our coefficients. 2 times 6 is 12. X times x cubed. Remember, if there's no exponent, you can put in a 1 as a placeholder. So 1 plus 3 would give us x to the 4th. And then y squared times y to the 4th would give us y to the 6th. Then the last thing we're going to do here is simplifying expressions. So this is kind of combining everything we've done into one problem. So when simplifying expressions, be sure that each base appears only once. Remember, a base, if you have x squared, x would be our base. So each base is only going to appear once. In other words, each variable will appear once. There are no powers of powers. So a simplified version would not have like x squared to the 3rd power. And then all fractions are in simplest form. So here, what we're going to do to solve this is I'm going to go ahead and do this first one in blue here. since it's 3xy to the fourth and we're squaring that, we need to distribute that square. We need to square everything within the parentheses. So 3 squared would give us 9, x squared, and then since we're doing y fourth to the second power, we would multiply 4 times 2, which would give us y to the 8th. Now the second half, I'll do in red here. This time, we actually have to do a couple steps here. The first step, since we have negative 2y in parentheses and we're squaring it, we need to distribute that squared into the parentheses first. So negative 2 squared, negative 2 times negative 2 would give us positive 4. Then y squared, and then that gets raised to the third power. So in this case, we're going to drop down our 9x squared y to the 8th. Then we have to distribute our cube here. So 4 cubed, 4 times 4 times 4 would give us 64, looking at the wrong problem, would give us 64. Then y squared to the third power, we would do 2 times 3. That would give us y to the 6th. Then we multiply here. 9 times 64 gives us 576. Then we would have x squared, because this one doesn't include an x. And then y to the 8th times y to the 6th. Since we're multiplying the powers, we would add our exponents. 8 plus 6 would give us y to the 14th. And that would be our answer right there. So that's kind of a quick walkthrough of that first lesson. I'll do another video in just a minute here going through the second and then the third lesson. And hopefully that helps you guys out. If you have any more questions, feel free to reach out, text, email, call, whatever you need to do, and make sure we can get this all figured out.